In Part A, either the desktop computer will boot up or it will not. We show this as two branches on a tree diagram. One is labelled D to represent the desktop boots up, and the other is labelled D' or not D to represent the desktop does not boot up. The desktop will only boot up 90% of the time, so the probability that the desktop will boot up is 0.9, and the probability that the desktop will not boot up is 0.1. We mark 0.9 on the branch labelled D and 0.1 on the branch labelled not D. Similarly, either the laptop will boot up or it will not. So we draw two more branches from D and label one L to represent the laptop boots up and the other not L to represent the laptop does not boot up. We draw the same two branches from not D. The laptop will only boot up 70% of the time, so the probability that the laptop will boot up is 0.7, and the probability that the laptop will not boot up is 0.3. We mark 0.7 on the branches labelled L and 0.3 on the branches labelled not L. Following along each path in turn, we can record the possible outcomes. In Part B1, the probability that both the desktop boots up and the laptop boots up is found by following along the branches D and L and multiplying the probabilities written on them. That is 0.9 times 0.7, which is 0.63. So the probability that they both boot up is 0.63. In Part B2, the probability that the desktop boots up but the laptop does not boot up is found by following along the branches D and not L and multiplying the probabilities written on them. That is 0.9 times 0.3, which is 0.27. So the probability that Stefano has to use his desktop computer is 0.27.